Hi, this week I've been very busy working on multiple lighting and also like dynamic lighting in the fragment shader. So this is an example scene. We have the bunny model and we have two lights working here. You can see that the blue light is to the left of the bunny and the pink light is to the right. So I'll uh, I'll show off the code in a minute, but these are fully dynamic lights, right? So none of the lighting information is baked. Um, they can be moved around. You can see the position changing. Um, yeah, so also the colors are fully mapped, so we can change it to white, or we can, um, change the colors how we want. So yeah, it's pretty handy. Currently in the shader, you can only have up to 10 of 10-point lights on one object. Or influencing an object. I haven't gotten around to limiting that or determining which lights should be sent in, right? If you've got 20 lights, you kind of don't want to take the lights that are far away from the object that you're currently processing. Um, so yeah, there's still a lot more to do, but it's nice to finally have lighting working because I put it off for absolutely ages. So yeah, we're getting there. I also fixed a few things around the place, like the key bindings and stuff for ImGui weren't mapped correctly, so you can now delete stuff and type in lowercase, uppercase, So it's all good. It's all good stuff. The next thing I'm going to work on is probably materials, because at the minute the lighting shader doesn't take any material properties in, so I have to have materials actually applied to each mesh, and it's just figuring out the best way to do that, because like with a mesh that has multiple a model with multiple meshes, um, like the nanosuit, you can see has a material per mesh, right, on this model. So yeah, I don't know how I'm gonna Unity and other engines have like a shader per material and a material um, per object. So really, I've broken each object down into the component meshes. So like this nanosuit has 7 meshes in it, and I guess each one of these should have its own material, right? Like an arm material, a leg material, because that's how it's split up. Um, so yeah, it's just finding the best way of doing that. I also fixed an issue where the models that I was importing were appearing upside down. That was just because of a flipped um, up unit. So I had up as positive y on my V model matrix, um, but for some reason that was causing everything to be upside down. Maybe it's just the coordinate system in the rendering pipeline is different to how they were exported or something. I don't know. But yeah, that seems to have fixed it. So yeah, I don't know if it's the correct fix. I'm sure I'll find out later if I've done something wrong. There is something wrong with my lighting positions. Like -10 goes to, wait, where's 0 0, and if we go 10, it moves it to the right. But if I do, which is correct, right? I want right to be positive x, forward to be positive z. Um, but then up and down on lights, if I do like -10, you can see it lifted it up, and if I do +10, it goes downwards, right? But if I do that with my mesh, 0 takes it up, and then +6 brings it up again. So it's working fine on the mesh, but not on the lights. So I need to investigate that. There's something that I found out literally just before I recorded the video, but we'll have a look at some of the. Oh yeah, I made this performance stats window just because I hated having the console print out all the frames per second, but I know this frame time isn't correct. I was just just messing around with it, because obviously this has got 2000 data points on it, and the speed at which this graph moves is dependent on the frame rate, because obviously it's going to add more data points to the list, and it'll move faster. But anyway, let's have a look at the code. Okay, so here we are in our forward renderer class. We get the scene and whatever program you want to, that shader program. So you essentially render the whole scene with one program, and that's going to change in the future. But yeah, so this just renders to the texture, and then after we've set all the do-transform stuff, before we get all our entities to render, we're setting the lights, which, as this comment says, should really be done in the entity loop, because you want to get the lights that are going to impact that entity the most. So yeah, so this is going to move into here somewhere first, and we'll do some like range checks or whatever on it. So yeah, so that comes down to the set lights thing. This uses obviously the Eris my entity component system library, which I have to update to use structs instead of classes again. I think I'm going to change that back now. But yeah, so we get all our lights. I had an interesting problem in here. So the problem I was having was this was set to a standard 10. Like this, I decided arbitrarily that 10 was going to be the most amount of lights. Wasn't any reason for that, but just from like a base standpoint, I wanted multiple lights. I thought 10 was a good number, so whatever. But I had this as 10 instead of the light length, the number of lights. So that made a problem, right? Because I assume this, when we create our uniform and we give it a length, this will kind of allocate the memory. Okay, save this block of memory for the lights. We're going to put the data in there later, which is fine, right? But if I have 10 on here, this is a pointer to this light positions array. If I only have 2 lights, it's going to point to memory with an array of 2. But then all the memory after the array can be used for whatever, right? Whatever any program wants to use it for. So I was saying that my array of light positions is 10, but it's not. It was 2, right? So it was putting whatever garbage data was in RAM at that time, in the memory at that point, into the light array, and I was getting flickering, right? Because it was interpreting the data that was stored there as light information, or vectors, you know. And yeah, it wasn't vectors, it was just random information that was there. So that caused me a little issue. It took me, you know, maybe an hour to figure that one out. But yeah, I just had to use the actual correct length. I mean, it was a stupid mistake. I really shouldn't really hard code values like this, but you know, I was just trying to get it working. So I thought maybe that would be quite interesting to share, because sometimes seeing other people's failures is more helpful than seeing, you know, the finished product only. So that was the only real big thing. So we'll have a look at the shaders now, I think. Okay, so one of the things that I was struggling to get my head around was how I could pass the lights from the vertex shader into the fragment shader, and I was trying to pass a uniform of lights into here and then pass it through at the end without actually doing anything to it, which turned out to be stupid, right? It's been a while since I worked on shaders. The last time I actually seriously worked on shaders was in university, so all the other shaders that I've had up to now have kind of been like copied and pasted and stuff. So this is the fragment shader, and at the minute I've got a function for directional lights and I've got one for point lights. I'm gonna have one for like spotlights and stuff, but I didn't get around to it this week. Basically, all of this code, the lighting information, I've just been learning it from um, Learn OpenGL, which is like a great website tool for learning. So this is just from the lighting and then multiple lights. It explains. It's really good. If you're trying to do anything, even if it's not in OpenGL, like this isn't actually GLSL code. It's very similar, but there is differences. Like I have to use this varying def and like inputs and outputs instead of varying um, uh, identifiers at the top, right? Ins and outs and stuff. But you know, it's super similar. None of this code actually differs at all, I don't think. But yeah, so super good resource to use. Yeah, so if you want to know loads about it, read there. But essentially, the point lights have attenuation, which is kind of the light fall off, which comes from here. These are just values that I took from a resource linked somewhere on the internet. It might have been from the learnopengl.com, but I can't remember if it was for sure. But yeah, so I really can't say much about it. It's just lighting calculations. So yeah, I think I have a few other things on my checklist. So I wrote a quick checklist the other day. I was like, figure out why shaders were flickering. That was the memory buffer array problem. Fix characters in ImGUI. Did that. So I've got some other stuff like change eris components to be structs, rename replace component to be update. Because I think that's kind of annoying. Because if it's a struct, we're gonna have to replace it every time we alternate. I was thinking about returning it as a ref, but I'm not sure if I'll do that still. There's some other things like the asset window was kind of bumming out the frames per second, but there's stuff I want to look into. So yeah, that's kind of like a sneak peek of what I'm gonna try and do for next week. But yeah, it's not actually like a huge amount of work, but it feels great to have lighting working. I can't wait to like continue on this trend because just small amounts of effort got like a big output of like a, you know, it looked like a lot of work when it didn't feel like a lot of work. So that's good. All right. Thanks for watching, and I'll see you next week.